Hello, everyone. My name is Mario Ceste. I'm here to talk today about the Presto connector for data control. So before we get into the connector, obviously we need to introduce what data control is. Data control is a cloud-ready data platform that allows you to manage large quantities of data from disparate data sources. Essentially, at its core is we're trying to provide a methodology and tools for mature data management. So that kind of falls into three main pillars. Data management, obviously. We've come up with a methodology, what we call data levels, which I'll describe here in a second. We obviously want to track data lineage, as data comes into your system, to be able to track where it came from whenever you process it, to be able to, keep track of where that data came from, what's been done to it. So if you're using data downstream, you can understand its origin. If you're responsible for data, you can determine where that data is gone. We've built a file system API that allows us to interact with a lot of the major cloud platforms, specifically S3, HDFS, Google, and Azure. We built a schema registry, so as data comes in, we can create schemas from the data that help us better understand the data. And then what I'll talk about here in a minute is this concept of data tables, which allows us to be able to access our data in a table format and using SQL. And then we have a concept of milestones, which allows us to keep track of data as it moves through the system and make sure that it's hitting some of those key milestones so that you can know if data is not being processed, you can alert whoever is responsible for that. And then other aspects of the system, which I won't really talk too much details about, are the streams processing. Obviously, if you're bringing in data and processing it, you need a platform to be able to perform those operations at large scale. So we have that as well. And then we have the ability to manage users, grant people access. So that's essentially what data control is at a very high level. What we have this concept of data levels, which allow you to store and retrieve your data as it moves through the process. So level 0, that's your raw data. As data comes into the system, we store it in files and keep track of it forever. Eventually, maybe age it off into some storage that's cheaper if necessary. And then level 1, we take that data and we kind of convert it into a file format that's consistent. So as we get in data that's CSVs, JSON, XMLs, whatever it may be, we don't want our, that's the data lake concept. We don't want our users to have to fumble through all these different file formats. So we store in a consistent format. We use Apache Avro, and then allows us to also track schema evolution. Since everything in Avro is a schema, as data comes in and gets ingested, we associate a schema with it. So now from your catalog, you can better understand all the different structures and fields and things like that are present within your data, which is then eventually going to allow us to be able to query it. And then some of the higher levels are, where you get into that common model and analytic model. So that's level 2 and level 3. This is kind of a quick screenshot of our catalog. So we have data sets, the ability to see all the data that's in your system, how much data is there, how many files, how many records, things like that. And then you can kind of dig into some of the schemas. So a lot of this data here that I have is public data that we can bring in from the AWS public data sets stored in S3. And so we can see, as we get the raw data in and create schemas, we can better understand those schemas, and then we can drive down into the actual content that we've ingested. So why Presto? Obviously, probably preaching to the choir here with a lot of these things, but I think it bears repeating. Kind of what led us to integrating Presto into our platform. Probably one of the key things is the ad hoc querying. We had a platform that allowed us to ingest and manage data, but it wasn't really geared towards giving people access to information. I've been in the big data field for a very long time now, and as much as I enjoy processing data, I'm not processing data just for processing data's sake. I want to actually do something with the data. And so being able to run SQL queries, very easy language to learn, against your data not only empowers me as an engineer, but also empowers the end users to be able to access that data. So as soon as new data comes into the system, users can query it. Whereas before they'd have to like open up flat files or download them through our API or whatever it may be, or wait for that data to end up in some downstream system that was geared more towards them. So now we give them more direct access to that information. Then selfishly, we can use SQL ourselves to do a lot of our batch ETL jobs. So it simplifies our transformations and filters. Obviously, once again, writing SQL is a lot easier than writing Spark jobs. Even if you're writing Spark SQL, building your, standing up and running your Spark cluster, all those types of things. We can easily combine data. I can query across multiple tables. Then we can build data marts that allow our users to access maybe a subset of that data. And we can do this all through SQL, which is great. And then, you can play around with the data. You can understand it, triage it, sample it, all using, using SQL and using Presto as an engine to perform those operations. So in order for Presto to fit into our platform, we had to come up with a concept called data tables, which is kind of similar to, it's kind of like a cross between Hive and Iceberg. But essentially, we created two concepts, externals and managed tables. So external tables are a way for us to continue to process data, create files, and be able to query them through SQL. So you get the benefits of being able to query, but you don't get the benefits of how data is organized. So it's kind of similar to Hive external tables. And then we have managed tables, which allow you to actually use SQL to create and populate and modify your tables. So in order for us to integrate into Presto, we basically built that data tables abstraction, which fits nicely into the Presto connector API. So we kind of modeled a lot of that after what the connector needed, obviously, because that was the reason why we were building it, is to provide that connection between our data is being ingested and Presto itself. So we built the Presto connector so that we can select from those tables. So you can select from any external or managed table. Managed tables are able to take advantage of partitioning and bucketing, because like I didn't mention on the previous slide here, but managed tables have support for partitioning and bucketing. And then you can create and insert into managed tables all using SQL. So we get all this great, benefit and power from, Presto, not only from an integration of the SQL aspect, but also from the performance piece. And now allows our users to be able to ingest and manage their data, through Presto in addition to the normal ETL route. And so here's a quick, just a little demo of our system, exposing our tables here on the left, getting some of the details, and then running queries here. So obviously users can use the Presto CLI, but they can also use our front end to be able to query directly against the table. So if you have any questions, feel free to reach out to me. You can email me, or you can reach out to me. I'm more active now on the Presto Slack channel, but thank you. Appreciate your time.